Well, our talk will be about self-service website monitoring with Checkmk. First of all, I will introduce ourselves. This is Thomas Schmitz.
Hello, everyone.
My name is Michael Wulff. We are both from Rewe Digital, or Rewe Digital, if you pronounce it in English, the IT service provider of Rewe Group in Germany. We work in the team Observability. Our team offers different monitoring solutions for both systems monitoring and application performance monitoring. I have been working at Rewe for 25 years, and Thomas is with us for 4 years now. The solution we will present today was mainly developed by Thomas. Okay, first have a look at the agenda. The presentation is divided into 6 sections. First, we present some information about our company, then how we use Checkmk, then we talk about the actual state of website monitoring at Rewe. We will introduce the concept of our self-service website monitoring, then we will illustrate this concept with one example, and in the end we give a short outlook to website monitoring in Checkmk 2.3. Okay. Who are we? First, we will have a look at Rewe Group. Rewe Group is one of the big German retail companies with supermarkets and other business units. In 2022, we generated total external sales of 85 billion euros. Those of who they are from Germany, you will know Rewe and Penny supermarkets from the list here. Those from Austria and Eastern Europe surely know Billa and Penny markets. Then we have do-it-yourself stores like Tome. And last but not least, the travel and tourism segment with tour operators and travel agencies like Der Tour, ITS or Kuoni. The next slide is about Rewe Digital. We have 2,250 IT specialists, 2 of them on stage today. We provide IT services for more than 7,300 markets in Germany with nearly 200,000 employees. And we control about 80 data centers in Germany, and we have 10 administrative locations in Germany, Austria, Spain, and Bulgaria. So, what do all these IT specialists do? A lot of them are software and requirement engineers. And of course, our merchandise planning and control systems, for those who speak German, it would be the Warenwirtschaftssystem. Well, these systems and the logistics systems and of course the Rewe online shop, they are developed in-house so that we can make ourselves unique from our competitors. Then of course we have not only developers, we have DevOps engineers and systems engineers, and of course we do monitoring. So now we come to how we use Checkmk at Rewe Digital. I will only talk about our production environments. Of course we also have development and test environments. So our main monitoring environment is Checkmk 2.2 on Red Hat Enterprise Linux 8. We have 1 central site and 8 remote sites with about 5,400 hosts, mostly Linux and AIX. In the future, we will also do Windows monitoring with Checkmk. We have more than 325,000 services and about 200 users. Well, what do we monitor with Checkmk with this environment? We do systems monitoring, storage monitoring, database monitoring. We have a lot of plugins and local checks with custom monitoring scripts. And we do availability and content checks. No, that's the wrong. Well, the users are DevOps and system engineers. And normally they only see those systems they are responsible for, which we achieve with contact groups in Checkmk. Okay, then we have another environment, the self-service monitoring environment, We do not call it self-service website monitoring environment because in the future we might also add some other self-services for other topics to this environment. This is also Checkmk 2.2 on RHEL 8. There, of course, we use the check HTTP active check in version 2.2. The new version is not yet available. We have one central site, we have one remote site, which is for URLs in the demilitarized zone or in the internet. At the moment, we have about 600 hosts. We are still in the migration process from the old solution, which I will explain in a few seconds. We have about 1,600 services, 100 users. In this case, the users are mostly software engineers, so those colleagues who develop the sites, requirement engineers. And currently we have 800 websites. In the end, it will be more than 300 websites. Okay, what is the actual state? We monitor, as I already told you, we monitor about 3,000 websites. This number is quickly increasing. In fact, at the moment we already have 3,500 websites. What services do we monitor? Of course, the HTTP status code. Then we monitor if the request runs into a timeout, the response time, the content check, which is a string or a regular expression to find on the website. We do login with basic authentication, and then, of course, certificate validity. So this, at the moment, we have a self-developed solution within SCOM. SCOM, most of us will know, is the monitoring solution from Microsoft. It's called System Center Operations Manager. This is for historical reasons, which I will not explain here. The configuration is done by XML files. But with this solution, we have some problems. First of all, SCOM has a very user-unfriendly interface. It's very slow, not intuitive. The customers have no access to the configuration files, but we get a lot of requests concerning the configuration details, which then we have to look up. The architecture is not scalable, so we do not know when all this will come to an end. Testing is very time-consuming because from changing the XML files to the activation of the check, it takes more than 30 minutes, so you spend a lot of time waiting during testing. And then, last but not least, it was developed by someone who is now in a different team, and he's the only SCOM expert we have in our company. And neither Thomas nor me want to become SCOM experts, and that is also the reason why we want to, or one of the reasons why we want to move the Windows monitoring to Checkmk in the near future. So what is the concept of our self-website monitoring? As I told you, I think I told you, we're still in the process of migrating from the old to this new system. Well, first of all, we created a subgroup in GitLab. We use GitLab. And there you can see each team that wants to have their website monitored has an own project in GitLab where they can edit the configuration files, which now are in YAML, written in YAML. Then we have a sync project, and if one team member edits a YAML file and does a commit, then a trigger is running a CI/CD pipeline. And in the sync project, the check and do changes jobs will run. These are Python script. The check first checks the syntax of the YAML file, and then the do changes job propagates the changes firstly into a configuration database. And then on the Checkmk side, we have a cron job running once a minute. And the cron job checks the database for changes. And if it detects any changes, these are propagated to Checkmk via the REST API. And what happens exactly then? First we add a new host, if it not yet exists. The host corresponds to the domain part of the URL. Then we create or edit several rules. And in the end, we activate the changes. and then all this takes about 3 to 4 minutes from the commit to activating the changes in Checkmk. We will show an example how to add some websites. This is, of course, a constructed example because we cannot show our real production environment here. We will just monitor 2 Checkmk websites, the forum site that we saw in Marcel's talk already and in the works site. So let's have a look at the YAML file. At the top you see an application ID. This means that all the checks in this file will belong to this application. Of course, this is a fake number in this case. Then we have the certificate lifetimes in days, the response time in minutes, the timeout in minutes, in seconds, sorry, of course, in seconds. The content expression, this is a regular expression. A dot means, of course, any character will match. A location internet, that is how to know which site to use. As I told you, we have the site in the demilitarized zone, which is responsible for URLs either in the demilitarized zone itself or in the internet. So this check would run on that side. Then we have this automatic restart parameter. This goes a bit beyond Checkmk because we have an event management system, and that can trigger a restart of the web server in case of an event as a response to the event. And this is to minimize on-call operations, and which is especially important during the night, so that nobody has to be called by phone. We try an automatic restart, and normally the problem then is solved. Okay, then we have the checks itself, the 2 websites here, the works page and the forum page. There we have the criticality. The criticality corresponds to the service level in Checkmk and controls the type of escalation. So the on-call operation is only for criticality very high. Then we have a label that corresponds to a service label in Checkmk this check will get. And then we have content expression here. So on this level, you can override all parameters from above. Above we had content expression, the dot, and now we have changelog. And then for the other URLs, we have some different parameters. Okay, what happens if I do a commit? The pipeline will run, and here we see the result. The pipeline ran about for 1 minute and some seconds, and we see that the check changes and do changes were both successful. And now the configuration, as I told you, has been written into the database. And on the Checkmk side, the cron job will fetch the changes and propagate to Checkmk via the REST API. And then in Checkmk we have 4 new services. Remember that this is still Checkmk 2.2. And let's zoom in because we can't read anything here. Here we have the 4 changes, 1 change for the certificate and the other for the rest. Okay. Now, what will happen in Checkmk 2.3? The new active check has already been explained in detail by Marcel, so we'll just focus on the things that are interesting for us. We have a massive reduction of rules, as Marcel already explained. Several websites can now be included in 1 rule, and we have no additional rule for certificate monitoring. And of course, we have also fewer services. Then there are some problems fixed with HTML body parsing. This is that some information of the body don't in the header do not correspond to the body. Then, yes, authentication tokens can be stored in the Checkmk password store. We have HTTP 2.0 support, which we need for some websites. And then, okay, at Checkmk, uses OpenSSL 3.0 instead of the old 1.1. This, of course, also affects the old Check HTTP plugin. There is a workaround available in case you have some older devices which do not know what OpenSSL 3.0 is. Then, for us, an important thing is the improved information in the summary details. This is a screenshot from 2.2. We see the summary, but the details are empty. And in 2.3, with a new version of the active check, we have a lot of details, the URL, then we have the follow redirect, as Marcel announced. So these two URLs can be directly called here and tested here. We see these fixed parameters, the get method and so on. And then at the end, we have the parameters that are checked. For example, here we see the content checked, the expected regex in body is username. And in case of an error or warning, in the old version, it was often difficult to find the real cause of the problem. And here it's much easier because we have this warn and critical tags, and then we can much faster identify the cause of the problem. And this, of course, leads to much better notification messages. So what is our plan for upgrading to Checkmk 2.3? Of course, first we will upgrade the environment. As Marcel explained, the Check HTTP rules are not migrated automatically to the new version, but Check HTTP, the old version, is now deprecated. And we want to migrate the checks per folder, that means per team. There's already one team who said, I want to be the first. We will deactivate the old checks via a script. Then we will add the new rules via another script based on the configuration in GitLab, respectively in the database. So we have all the configuration in the database, and if we have a script, then it's the same if I migrate one rule or I migrate 100 rules. Then we will activate the changes, and if everything works, delete the old HTTP rules. But we will wait with the migration from the old SCOM solution to this. We will wait because first we want to upgrade the environment, because we do not want to migrate from SCOM to the old active check and then another migration to the new active check. We will directly migrate the main part of all the old checks to the new active check in Checkmk 2.3. Okay, question and answers.
Thank you very much. By the way, is it true that you wanted to move away from Checkmk for website monitoring?
We had a discussion about which tool to use, but finally we decided to use Checkmk.
You were very afraid. I mean, it's only 2,000 services, but... Okay, we have a couple of questions. First one from Ralph. Yeah, can you speak a little bit more about your Checkmk site setup? How big are the servers that you have? I mean, you have this one big environment. I think that's what we are talking about. How big are this? How big are the servers? How much CPU? How much RAM do you have? Do you know?
I think that we have 8 sites, and each one have around 12 CPUs. And how many RAM? I think it is 36. Am I correct? At the end, I need to check our documentation, but on that end, we have around 800 servers per site at the moment.
Yes, I think we increased the number of CPUs in the past because we had to increase the check and helper sizes.
Now we need to increase the fetcher. It's ongoing.
Regarding checker helper, I think I saw one question where someone asked, do you also adapt the checker helpers automatically, or do you do that manually?
We do that manually. Yeah.
Do you have to do it often? I mean, if you add so many more active checks.
Basically, we are checking how many checks we will add and increase it before we import them. and then monitor the performance graph.
I think 1 or 2 years ago we had to increase them very kind of often, but now it's rather quiet, I think.
How big is the self-service monitoring instance? How many CPUs and RAM do you know?
At the moment, we have only 4 CPUs. We are monitoring 600 secs, so we are checking how many CPU we need to investigate for this.
So 4 CPUs only at the moment. Okay, that's not
That's
much.
not so much. We may need to increase here.
And why do you have 2 Checkmk instances? Why do you have your data center server monitoring and your self-service monitoring?
Yeah, basically in the self-service, it's due to these Checkmk activations. For the self-monitoring, there are several activations when the user is changing something in the pipeline, and we need to separate that. And want to have a separate environment for this self-service monitoring because there are a lot of rules, and we need to want to have them separated.
How often are there changes? Like how often do you, not right now or in the future, how often do you think there will be new websites added or changes to the monitoring?
Yeah, I think a few times a day, because there are also some automatic ways where they change the YAML file in the GitLab automatically via a pipeline one when they start an application or something like that.
Someone is asking how you do the remediation. How do you do the automatic restart of the web server?
Okay, I talked about the event management tool. This is tool we use netcool from IBM, and we send you notifications from this Checkmk to netcool, and in netcool the event triggers a job in an automation solution. We have VMware vRealize Orchestrator of VMware, and then we have some parameters. Netcool sends some parameters to these vRealize Orchestrator, and the Realize Orchestrator has access to the server where the web server runs, and then it can restart the web server. And normally this helps, because if you call someone during the night, this web server has a problem, what does he do? He restarts the web server, and then he goes back to bed. And in 90% of the cases, this helps. So we could reduce the number of calls during the night. We could reduce this number massively.
Okay. You also do context checks or content checks.
Content checks. Mm-hmm.
Are you happy with that you can just do the content checks on the HTML response? Or, we have basically Harry asking, Harry Hirsch, you know him from the documentation maybe, if you would also like to check, for example, for valid DOM trees or for certain DOM nodes.
Yeah, sometimes we have a request, for example, for JSON response to pass something in a JSON which we cannot do in a regular expression. That's, but in most of the cases it works. So,
in most cases this is sufficient.
Sounds like we need check JSON. Do you have high availability or disaster recovery in place for your entire monitoring?
Not real high availability, no.
Basically, they're based on VMware, and when the ESX host is crashing, it's automatically moved to another ESX host, but we have nothing else.
But do you have any issues? Or did you have issues?
No, the environment is running for the last 4 years without any issues.
I think we had more problems with the high availability feature.
Than with Checkmk.
Yes, because if you have no outage, then you have to administer the high availability feature, and this often causes problems.
Okay. Almost over. Thank you very much for presenting it here. Thanks very much for pushing us to get this feature done. We are very happy that you really gave us a lot of feedback as well, and we hope that all of you benefit from that as well. And with that, thanks very much.
Yes, and thanks to you for developing the feature so
I didn't do it.
so rapidly, but for your company. Okay.